I am back. And so, yeah, I'm not kidding, I'm back. So today, I would like to talk about something that I actually found a little bit interesting. Some people actually will argue that when we have a square root of some values, we should always end up with two different results. And where did I find it? I actually found the comments of those those people's comments from other people's videos, and actually that is actually pretty upset. So what they are arguing is, such as in the false example, if we have square roots of 9, they'll argue that we should always end up with two different results, which is plus or minus 3. And again, we know that 3 squared is 9. But of course, negative 3 quantity squared is also 9. Similarly, if we have square root of 4, they will argue that the answer should be both positive or negative 2. Something like that. And furthermore, they'll argue that if we now try to add these two values together, because we have two options for each value, we should actually end up with 4 different results. Meaning that the expression will actually end up with 4 different answers, such as we can have positive 3 plus positive 2 as our first option. And then we can have positive 3 plus, as we change the second result, which is negative, we'll actually yield to a different result. Similarly, we can have negative 3 plus, not so good at it, plus positive 2. And last but not least, we can have negative 3 plus negative 2. Things like that, which actually will end up with 4 different results as they want. So, of course, if we talk about values like negative under the radical sign or the square root sign, they'll think this they will make the statement even stronger, because they will say now the result is no longer a real value. It will be valid to say that it will always end up with 2 different results, which is, in this case, they will claim that the square root of negative 1 will be actually equal to not just I, but both plus or minus I. Where of course I is what we call the imaginary unit, which is how we define the square root of negative 1. Okay, and again, the definition is just I squared is equal to negative 1, which is actually fair. And of course, if we think what's the square of negative I, of course we will get negative 1 as well. But the problem is, when we actually use the radical sign, do we get both values, or do we get 2 or more values? In fact, we cannot. Okay, but they will ignore this definition here, as the radical sign or the square roots is not just a symbol, but an operation that can only yield to 1 result at a time. So why can't we just say that the square root of negative 1 is both plus or minus I? If we even if we solve for the equation x squared equals negative 1, we should get 2 different solutions. Let's consider the following. If we have square root of negative 1 plus the square root of negative 1, of course, if we think it as some value, which is, in this case, it doesn't really matter whether if it is a real number or a complex number. Let's just call it x again. Then we have x here to replace square root of negative 1. And then for the second term, it is actually the same expression. So we can also express it as x, meaning that now we actually just have the expression x plus x, and of course by basic algebra, if we add the x with another x, we should just have 2 copies of x, like that. Now, if we're trying to use their fallacy here to try to get the result, let's see what happened. First, let's say if we choose the first value be positive I. Okay, so we will choose option number 1 for the first case. Let me use a different color. Okay, option number 1, which says that the first term is going to be positive I, like this. And then for the second value, we're going to choose the second option, meaning this time instead of positive I, we're going to choose negative I. Okay, what's gonna happen? Now, if we choose it this way, we will actually end up with positive I plus negative I. But what's positive I plus negative I? Well, it's just I minus I, right? Where I is, again, we call it the imaginary unit, which is just another way to kind of using a symbol to refer to something not on the real line. And again, you can just think or treat it similar to just a variable, like in algebra. Meaning that now if we have I minus I, we will actually have the 2 i's cancelled out and end up with just 0. But is it true? Well, remember, we just said that if we try to replace it with any other values or any other variables such as x, we will actually end up with 2i or 2x. So if we have 2x, which is equal to the expressions that we started off, which ends up with 0. Since 2 is not 0, we can actually divide by 2, meaning that we now have 2x is equal to 0, and as we divide by 2, we end up with x is equal to 0. What does that mean? It means that our expression x, which is square root of -1, is equal to 0. But clearly it's not true, right? Because if this is true, as we square both sides, we'll end up with -1 is equal to 0. And again, these two are not the same value. So what makes the problem of not allowing to do it? The biggest problem that we actually have is the option that we choose. When we choose the value of what each term means, we have to stick it with the same value as we choose it. Meaning, since we already choose the first term to be positive I, and then for the second term, it's just the same as the first term, we have to stay on this. We have to use the same value in order to do the calculation. So if we choose the first term as positive I, the second term is automatically becoming positive I as well. Similarly, if we choose the first term to be negative I, the second term becomes negative I. So in that case, we should only end up with either I plus I or negative I plus negative I, and then to get the result. Now you may ask, but in class we always say that the result should only be I plus I, but not the other way. Why would that be the case? Well, this is something that we call the branch cut in complex analysis, which is actually a fundamental topic that shows that when we try to get square roots or even the cube roots or things like that, okay, if we try to take the root and of some values, especially if we're trying to think it as like a solution of some polynomials, then we will always end up with 2, 3, or more results. And in that case, in order to define what we mean by using the radical sign or square roots or the fractional exponents, we need to choose only one out of those for one situation. Meaning that in this in one problem, once we decide what we choose to be our principal value or the branch cut, we'll just stick with it. For example, if we consider the circle here, or we will say that the unit circle here, where this part is the imaginary axis and this part is of course horizontal axis, is the real line, then we will have 1, I, -1, and -I here. If we try to consider all the points here on the circle and do the branch cut, we will actually get the following. If we have square of some value on the circle, which is actually, well, some value on the circle, which is actually equal to some value on this circle still. And again, that is because the radius is 1. So if we try to square this value, the radius is still remain the same. And that's why we choose a unit circle anyway. So let's suppose we choose the value that is, let's say, somewhere on here. Let's take this spot here, which is actually equal to, let's see, this is negative square root of 2, hold on, square root of 2 plus square root of 2i all over 2. And if we try to take the square, try to solve this equation here, we should end up with 2 results. But if we try to use this symbol here, the square root, we need to decide which one we're going to refer to. And that will be what we call the principal value. So because most of the time when we choose the principal value, we will actually take this side here, the right half of the circle, which does not include the, actually, excuse me. When we choose the principal value for square roots sign, we usually would like to take the upper half of the circle, except we will exclude this point here with -1. And of course, if we have some other values with the modulus is not 1, we will just take we'll just expand this circle or kind of shrink this circle to get what we need. Meaning that we'll actually take the whole upper half plane other than the negative real line here, not including 0, okay. This part here, the real line, as our branch cut, and also use this upper half plane without the negative real line to be our principal value. So if we want to use the -I as our principal value, it means that we just need to rotate or flip the or we choose our branch cut and as well as our principal domain here. So for example, if we want this value ending up with -2i, we just need to, instead of choosing the upper half plane to be our principal value, we will choose the lower half plane And of course, you can also try to, instead of having the branch cut at negative real value, we can just have it on the positive side, meaning that now we'll say that whenever we have a square root of some positive real values a, this is going to end up with negative value, or a squared. For example, it will end up with just the negative of this a value, such as in this case, square root of 9 will be forced to be negative 3 only. All right, and that's the reason why when we actually have the radical sign, instead of having 2 or more values, which will actually use a problem of, if we have addition or subtraction, we will have many options as a result. We can always only get one value at a time, and overall we might just end up with two different values at most, based on how we decide our branch cut or our principal domain will be. All right, that's it. Hopefully you enjoyed this video. I'll see you guys next time.